Hello, my name is Big Dave and this is Demystifying Unity, and as the first in the series we will be doing box casting, one of the strangest and poorly documented features of Unity is this box cast physics thing. There's a few. Raycasting in general is something that is kind of intuitive to people who read the instructions. It's quite easy. You have a point in space and you fire out like a gun. You fire out until it hits something, and then it returns the details on what it hits, and that's perfectly fine. There's a few other extensions to that in Unity, like Raycast All. There's things like Sphere Cast and other things like that. Sphere Cast is a bit more intuitive. It's a volumetric version of a Raycast in that you've got a point, it's now slightly bigger. And you've got a centre and you've got a radius and all this kind of stuff, and you kind of understand where this is going. Boxcast, on the other hand, is a little bit confusing because it's a Raycast in 2D that is a volumetric Raycast, but only in 2 dimensions. So where it gets confusing is the documentation doesn't really give you any visualizations. It's something that's quite difficult to visualize, in that the way it describes it is ambiguous and confusing. So it's a perfect topic to start demystifying, and that is what I have on my screen right now. What we have is 2 elements. We have a boxes array, which is this lovely thing here that's moving. As you can see, it's a little bit trippy. And we have the boxcaster, and I will go over the code for the boxcaster soon because the boxcaster is the meat and potatoes of the whole thing. Boxes, however, is just a box grid. It's fairly intuitive. You get 40 by 40, a spacing of 0.2, and then in the context menu you can create the grid from it. So there's nothing particularly special there except the fact that all this runs in the editor. You don't have to play, you don't have to build, don't even need a camera. There is no camera in this scene. This is literally just all editor stuff, all using gizmos to highlight where we're hitting with the raycast. So as you can see here, this boxcaster is currently set up to have a box, which is just a rectangle of origin 0, 0 and width 1 and height 1. Now as you can see, if we zoom in here, that this green outline here is clearly that box. It's got an origin at 0, 0, it's got a width of 1 and a height of 1. Now what does that all mean for the box casting? Well, under here you've got a direction, which is something that you need to plug into the box cast, and any raycast you need to tell it which direction to shoot the ray in, and distance, which is how far the ray should go in the detection. So in this case it's going a distance of 2 straight up in the y direction. And what we have here is a list of the game objects that it's hitting, and as you can see here, it's currently hitting 96. The mask is just a list of layers, so we're just having it go for everything. One of the neat things about raycast is that you can have it selectively ignore entire layers on your scene. So you can have it so that it only hits a certain layer. For example, if you wanted to do something that's usable, you put a usable object on another layer, and all you do is you raycast if you've hit something that's on that layer. It's really useful. I might do a full tutorial on raycast at some point, but there are plenty of them out there. What this is what this one is filling a niche that doesn't exactly exist, a visualization of how box casting actually works. So we'll take a look quickly at the code, and it helps if I actually open the boxcaster code. There we go. As you can see here, we've got the box, the direction, we have the distance, we have an array of the hits, an array of the game object hits, and the first hit, and the mask. Now you can see here execute in edit mode is activated, which means that alongside the gizmos, which I'll go over, but it's not crucial at the moment as to how it's going, it will run the update tick every time the editor updates. Now this is quite useful because it's not updating every frame, so it's not going tick 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 tick. It only ticks when you change something. not strictly true, but it means it's not updating 30 frames per second in the editor, which would cause a massive slowdown. So here we have two Boxcast. We have a Boxcast All and a Boxcast. As you can see, Boxcast All returns an array of raycast hit 2Ds. Now what are raycast hit 2Ds? Well, they are hits from a 2D raycast. What else would they be? So they take in a vector 2, which is the origin being the start point of the Boxcast, the size of the box, the angle of the box, the direction of the box, the distance you're going to go, and the layer mask. Now I've already talked about that. I haven't talked about angle yet. Angle is a weird one. Angle is not the same as direction, which is where some people get confused. Angle is the rotation of the box itself. So it says in the instructions, imagine you are casting a box over an area. And this is where some people get confused with it, in that if we what I've done is I've hooked it up to the angle of the Boxcaster. So if I start to rotate the Boxcaster, you can see there it's rotating, literally rotating the box that is casting. So at 45 degrees, you can see there it's a diamond with the center of the box rotated around the center of the box, and it casts up from there. And you can see there that there's a point where each of the boxes is overlapping with the collider itself, and the same at the top, as that is the shape that you're casting. So you can get basically a rupee shape if you're a Legend of Zelda fan. And as we move that about, you can see that each of the points. So what you're essentially casting is from this point, the shape of the box, including the angle, up a distance, in this case 2, which goes on half the width on either side, half the size. So if we made that 0.5, you would get a different shape. And if we made that 0.1, you would get a very thin cast up. And the same if we made the width 2, you can see there that the width of the box is 2, it's rotated around, and it's casting that line up. This is what's missing from the instructions and all of the forms and all the help pages. It doesn't have this in-depth look at exactly what the raycast is doing. So again, we'll rotate that 90 degrees, and you're just doing a line essentially. If we make that 2 again, and make the width 1 again, and make everything 1 again, you can see that it's going from the center of the box. Now this is quite useful in that from here you're going from the pivot is the bottom left of the box. The raycast is going from the center of the box, and it's very important to remember. People were confused as to whether it went from the bottom left of the box, the top of the box, the center of the box. It clearly states that it does go from the center, but again, ambiguity. It doesn't say whether or not it raycasts from when it raycasts, like at the end, does it do the box? So essentially what it's doing is it's taking the center point, doing a collider check, box collider check there, moving up a little bit more, doing another box collider check. Mathematically speaking, it's not doing that, but conceptually you should be taking it as it's moving up that, doing that box cast, literally just as if it was 0, 0. So if we make the distance 0, you'll see what I mean. So at 0, 0, you're literally at 0 distance. That is literally, you're just saying what is inside this rectangle, what's inside this square. We make that 2. What's inside that? Everything that's inside that, and then it's moving up the distance that you set until it gets to the end, and everything that was inside that, in case of this, everything that was inside that is returned as your hit. That is for raycast all. First raycast, however, as you can see in the code, I added first hit, which is just a simple box cast. So it returns the first thing that it detects as being hit. And this is where it gets a little bit weird, because as you can see, I've highlighted it in the sort of the cyan colour there. It's not the one that's at the centre. It's not the one that's at the left, top left, it's not the one as well. It's that one there. Now why is that? I have no fucking clue. Because if you do that, it becomes that one. And if you move it up a bit, it goes back. And move up again. Oh no, it's that one. Oh, it's on the bottom now. It is not random, it is deterministic, but I don't know exactly what determines which one you are hitting first. It might be the place it is in the hierarchy as to which one is actually first, but I have no clue, because there's the first one, and above it is the one below it. So you would think if it was first in the hierarchy, it'd be that one. And the one above it, it's literally, the way the grid works is it goes up and down the columns and then along the rows, so you would think it would always be the one at the bottom, but it's not. So I don't know what's causing that. But luckily, when you normally do a box cast, you won't be doing that. You won't be expecting to be having the entire area filled. You will just be looking for something in that area to be hit. If you do have multiple things to be hit, realistically speaking, you are getting something that's you're finding one thing that you're detecting. So it does that. I honestly, as for a demystified tutorial, why that is the first hit, or why that is the first hit, or as we keep going along, it does kind of keep shifting between those two, and then it changes, and it sort of does a little thing there. I cannot work for the life of me why it does that, but it does do that, and it's something to keep in mind when you are doing a box cast, that if you do happen upon something first, the first item it checks in its list just happens to be that item, and because it hit it, it returned that one. So I don't know how it gets its hierarchy, how it gets its ordering, but it does, and that's probably something that will happen with things like circle cast and sphere cast and whatever other cast you've got. Now I know that this kind of is a bit weird, but again, I have no idea why. Other than that, the box cast is fairly self-explanatory, and I'll actually go back into the code and show you what we're doing. So we are raycasting from the position of the box caster, and as you can see, we do have the ability to move this about. So it's going from that part of the transform to the box's center. So the center of the box relative to the root, which is there. We are then casting a box of size, box size, which is in this case 2 by 1. We are rotating it, we are sending an angle in based on the Euler angles of the transform, which in layman's terms is just the number of degrees in the transform. So none of the things are relative to the rotation of that, except for the shape of the box, as we do there. Really, the only reason I did that was to give me just to be able to use the handle to rotate things about, rather than having to type in stuff, just to give you a better visualization. You can set it in whatever angle you want. Generally speaking, you want to set in 0 because you're not really caring about the direction of the box normally, unless you are doing some kind of top-down boxy shooter thing, in which case, I don't know, you might want to just use a circle cast. Circle casts are simple, but if you do really need a box cast, then that angle could be useful if you're doing a sort of top-down angle or some kind of aiming angle, like a gun that shoots a box. I don't know. You make games. You do what you want. It's maybe a good tool, and it's a tool in your box, and if your tool's in your box, you're solid, because you can pull that tool out, and I'm trying not to go into innuendo, but I've gone there, so fuck it. Direction again, we talked about direction. Direction is the direction you're casting the box in. So if we go to Boxcaster again, we can increment next. So you can see there, you might want to cast the box in the angle in the direction that you're going. So if we make that 45, minus 45, and then make the angle there 1 and 1. It's obviously, you can orient the box to the direction independently of the direction. So as you can see there, you can set the angle to 45 and the actual direction to a vector that has an angle of 45 degrees to the perpendicular, which is fantastic. So if we do that up there and we make that 60, again that orients to there, or if you really wanted to, you just do whatever angle comes to mind. So 3. So it's nice that you can independently orient the box you're casting based on the direction, but if you do want to do something like that, you would have to figure out the angle of your direction, which isn't hard. You can do it with some maths, and some of the built-in functions can get you the angle based on the vector, and you can just get the z value out of that. And again, the distance, this is the distance you're casting, and because your box has a size, it is essentially casting the distance plus the width or the height, depending on which way you're doing it. In this case, if you're doing it that, it's plus that diagonal, and if you're doing it straight up, it's plus just the height, and if you're doing it straight right, it's plus the width on either side. So it can get a little bit weird when you try and conceptualize this in your mind, which is why this is incredibly helpful, hopefully, to people. And with that, I will now go over how I'm drawing those gizmos. This is another thing that people are kind of scared of when they first drop into Unity or any kind of 3D stuff, is matrices. And I am still terrible at matrices. I did them in university and I still don't quite get them. But luckily, all you need to do is know that you can rotate, translate, and scale a matrix, and the order that you do them in really matters. So you can see here that there are a bunch of rotations, a bunch of matrix transformations. So the TRS, static in a matrix 4x4, it takes a position, a quaternion, and a vector, scale, and creates a matrix out of that. So why am I doing this in Gizmos? Gizmos are fun. Gizmos are fun. Gizmos, at the most basic level, just draw stuff on the screen in the editor. At their most complicated, they can do so much. In this case, this is the most complicated gizmo I have ever written. So easily here, if we have some hits, loop through the hits, draw a cube at the position of the transform of the hit, and make it 0.16 size, and make it white. So what is that? That is just simply that white box. Simple. Each of the grid points white box. We draw a cube on it, it's a white box. For the first collider, we change the colour to cyan, and we do exactly the same thing, and you get that little cyan box there. Now, the next bit is slightly more complicated. We're doing a bunch of matrix transformations, and we're setting the colours. So colour green matrix equals this position plus the box's centre, rotated by the transform's rotation, and don't scale it. Keep it at 1 scale. And what is that doing? That is drawing the first green box. Now, why are we rotating it by that? Well, that's because we are taking that in as the angle. So we translate the matrix to the center of the box, then we rotate it, and we don't scale it. That is the order of the transformations that is getting done in that TRS. It moves it, rotates it, and then scales it. Because we're scaling it to 1, 1, 1, we don't care. So all that does is mean that when we rotate that, the whole thing is not rotating. The gizmo doesn't care about the rotation of the transform. All it does is it cares about the rotation that we put in based on the gizmos that we're drawing after it. Which in this case is a wire cube at position 0, as in 0 offset from the centre of the box, because we've essentially just stuck that in there. What we could do instead is swap this with a vector 0 and watch this. Look, it's all the way off the side. Why is that? Because we want to transform from the centre of the box, not from the 0, 0 point of the world, which is what will happen in that case. I didn't save it, that's why it's not updating. So the order of transformations is quite useful. This is a little bit off topic from the actual box, the box cast, but it's useful to know. So again, same here, we want to centre the point on the centre of the box at the end of the ray cast. And what is that drawing? Well, you guessed it, it's the box at the end of the ray cast. Again, we're just setting the Gizmos render matrix to something else. Then what we do is, down here, we decide to reset the rotation. We set the transformation point to the centre of the box again, and then we draw from 0 to distance. Now, technically speaking, this would be fine to just leave as matrix 4x4 dot identity and change vector 0 to that, and then do that. It's a little bit unwieldy and a little bit complicated because you're essentially adding those two vectors twice. I mean, it's not going to cause any issues whatsoever. But as you can see, it didn't change anything. But I just like this better because it continues the theme. And you only have to make one call, and everything you draw under that would go from the centre of the box, which is useful. So, a little bit of two things, a little bit of demystifying the Boxcast and a little bit of demystifying Gizmos. Although, maybe a simpler explanation. If you don't know what any of that last part meant, go read up on Gizmos and come back and watch this bit again, because Gizmos are incredibly powerful, incredibly quick to write, and incredibly useful just to display stuff in the editor that will help you design things. The last project I was on at work, I wrote a Gizmo that is basically just this, without all the matrix transformations. And it, once we gave it to the artist to mess about with, he was in Hog 7. It took me 10 minutes to write the Gizmos to show all the data, and, you know, sorted. So Gizmos are very, 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 very powerful, and they are incredibly satisfying to get one right, and to have someone else look at it and go, yeah, that's great. Make you look like a genius. So Gizmos, excellent thing to do. Box casting, not as complicated as the made out in the really badly written Unity scripting reference. So hopefully that has demystified some of what. Okay, don't give it a minus high, because that'll screw things up. Doesn't throw errors though, which is nice. Yes, so hopefully this has enlightened some people and given people ideas on how they can use Boxcasts. Me personally, I'm currently in the process of putting Boxcasts into a platforming engine as a way of, because essentially what you can do is, if you set the distance to 0, that's an angle, that's an axis aligned bounding box right there. Like that is an axis aligned bounding box. a box cast at 0 distance with the height and width of your collider. I mean, yes, you can do this with the inbuilt physics engine. You can just have in here game object component Physics2D box collider 2D. We turn off that box caster. Yep, so we hide that. And what was the size we made that again? 2 by 1.51. So 2 by 1.51. So while that's at the center of your object, so your offset is at the center, and we're setting the box from 0 to 0 from the actual origin of the thing. It's essentially the same thing, but that uses the built-in physics engine. Whereas this is if you want to build your own physics engine or utilize something that's a bit more deterministic than the Unity physics engine. Not that the Unity physics engine isn't deterministic. It's just, again, it's something that could be demystified. And basically, I've waffled on for the last 5 minutes, not really talking about anything. But until I come up with another thing to demystify, which may well be some of the physics engine, because some of the physics engine is quite obtuse and quite hard to get your head around, so hopefully some visualization of that might help. I will upload this project. It is 4 items: the box cast of the box grid, a sprite for the grid square, and this scene, and I will upload that and put the link in the description of this video. So until next time, I've been Big Dave, and hopefully I have demystified something for you.